Space debris is the tax bill for the space age. Every launch leaves a record. Some of that record becomes satellites, science, warning, navigation, and communications. Some becomes dead metal, spent rocket bodies, flakes of paint, shattered panels, bolts, lenses, scraps of insulation, and frozen fragments moving faster than rifle fire. Space debris turns orbit from a highway into a firing range. It threatens satellites, crews, national security systems, commercial constellations, and the economic logic of space itself. It also exposes the central problem of space politics. Every actor wants access. Every actor creates risk. Every actor wants someone else to pay for cleanup. This is the great civic drama of low Earth orbit. The trash goes 17,500 miles per hour, so the usual municipal solutions lack charm. The scale matters first. ESA's 2025 Space Environment Report estimates more than 1.2 million debris objects larger than 1 centimeter in orbit, with more than 50,000 objects larger than 10 centimeters. A 1 centimeter fragment can cause catastrophic damage because orbital velocity turns small objects into kinetic weapons. A 10 centimeter object can kill a spacecraft outright. Paint chips become bullets. Bolts become artillery. Space has a gift for making small errors behave like grand strategy. This is the first political fact. Space debris creates a shared danger without shared authority. Low Earth orbit has no mayor. No sanitation department patrols the sky. No court can easily seize a dead satellite and auction it for scrap. The Outer Space Treaty places responsibility on launching states, and the Liability Convention assigns liability for damage under certain conditions, but debris rarely behaves like a polite defendant. It fragments, drifts, decays, collides, and changes owners only in the poetic sense. Space politics turns on that gap. The nation that launches an object keeps jurisdiction and control over it. That principle protects sovereignty. It also complicates cleanup. A dead satellite from another nation remains another nation's object. Touching it without consent looks like salvage in one frame and interference in another. A cleanup vehicle with robotic arms can remove debris. The same vehicle can approach a functioning satellite. The tool has two faces. One face smiles at insurance companies. The other makes generals reach for the secure phone. This is why space debris is a security problem. Debris threatens the satellites that support missile warning, battlefield communications, GPS, weather forecasting, intelligence collection, banking timestamps, and maritime tracking. Orbit is no longer a prestige theater. It is basic infrastructure. When debris risk rises, the cost of operating that infrastructure rises with it. Every operator must track conjunction warnings. Every maneuver burns fuel. Every fuel burn reduces satellite life. Every avoidance maneuver interrupts mission planning. A satellite dodging debris is a truck swerving around bricks on an interstate. Enough bricks and the whole supply chain slows down. This creates a second political fact. Debris rewards disciplined actors and punishes everyone anyway. A responsible satellite company can deorbit spacecraft at end of life. It can design passivation systems, vent leftover fuel, discharge batteries, share ephemeris data, and maneuver when needed. That company still shares orbit with old Soviet rocket bodies, abandoned payloads, fragments from past explosions, debris from anti-satellite tests, and operators with weaker standards. Good behavior helps. It does not create immunity. The story gets sharper with anti-satellite weapons. The United States, Russia, China, and India have all conducted debris-generating anti-satellite tests. Secure World Foundation's 2025 Global Counterspace Capabilities Report states that these tests created 6,851 cataloged pieces of trackable debris, with 2,920 still in orbit at the time of the report. That is what a weapons test becomes after the press release fades. It becomes a hazard field with a long memory. China's 2007 destruction of the Fengyun 1C weather satellite remains the textbook case. It created thousands of trackable fragments and far more smaller pieces. Russia's 2021 destructive ASAT test against Cosmos 1408 created debris that forced astronauts on the International Space Station to take shelter. These events showed the plain physics of orbital warfare. A state can attack one object and threaten many states at once. Space warfare has poor manners. Debris has worse. That leads to the third political fact. Debris turns military signaling into collective punishment. A destructive ASAT test may signal capability. It may warn rivals. It may satisfy domestic pride. It also poisons orbital lanes used by civilian, commercial, allied, and neutral spacecraft. The blast does not respect flags. The debris cloud does not read doctrine. For that reason, debris-causing ASAT tests have become a norm-building target. Countries can condemn them without banning every counterspace capability. That distinction matters. States will keep developing jamming, cyber operations, dazzling rendezvous and proximity operations, and other counterspace tools. They can still draw a line around debris creation, because debris creation harms the operating environment itself. The weapon attacks the commons. The fourth layer is Kessler Syndrome. In 1978, Donald Kessler and Burton Coeur-Palais described how collisions in orbit could create debris, which could then trigger more collisions. The danger is a cascade. One collision creates fragments. Those fragments strike other objects. More fragments appear. The system feeds on itself. The phrase gets abused in headlines. The underlying concept remains deadly serious. Orbit is a finite shell system with altitude bands, inclination patterns, and traffic corridors. Crowding increases collision probability. Fragmentation increases object count. Delay makes cleanup harder. This is orbital compound interest, as designed by a banker with a grudge against civilization. ESA's report says mitigation alone cannot solve the existing debris population. Even with improved standards, active debris removal becomes necessary for long-term orbital health. That marks a shift from stop making the mess worse to remove the worst objects already there. This creates the fifth political fact. Cleanup is harder than prevention. Prevention means rules for new missions. Deorbit within a set period. Vent fuel. Avoid explosions. Share tracking data. Design satellites to burn up on re-entry. Move dead spacecraft out of protected regions. These measures are technically difficult, yet politically familiar. Regulators understand conditions. Operators understand compliance costs. Lawyers can staple the matter into submission. Cleanup means touching old objects. A derelict rocket body may tumble. Its structure may be unknown. It may contain leftover propellant. It may fragment during capture. It may belong to a foreign state. It may sit in an orbit crowded with other traffic. Active debris removal demands rendezvous, sensing, guidance, control, capture, and disposal. That is a full-contact sport conducted by machines at orbital speed. The first cleanup market will likely target the biggest risks. Large, dead satellites and rocket bodies matter because they contain mass. Mass creates fragments when struck. Remove a few high-risk objects and the environment improves more than if operators chase millions of tiny shards. The mission logic is plain. Remove the cannonballs before sweeping up the dust. Several companies now aim to make debris removal a service. Recent reporting described a planned debris removal as a service effort by Portal Space Systems and Paladin Space, targeting commercial operations in 2027 with a spacecraft and capture payload for smaller, tumbling debris. The idea matters because it moves cleanup from laboratory demonstration toward repeatable service, where governments and stations can buy risk reduction like insurance with thrusters. The sixth layer is data. Space debris policy depends on space domain awareness. You need to know what is up there, where it is going, who owns it, and how uncertain the track is. That sounds simple. It is a cathedral built from radar, telescopes, lasers, catalogs, probability models, operator disclosures, and classified military sensors. The politics of tracking is brutal. Governments hold sensitive data. Companies hold proprietary data. Allies share some data. Rivals share less. Small operators may lack resources. Some satellites maneuver often and publish little. Others die quietly and become math problems with solar panels. A 2025 debris emergency involving China's Shenzhou 20 spacecraft pushed this issue into public view after damage attributed to a micrometeoroid or debris impact forced a change in return plans. The incident sharpened the old lesson. Crewed spaceflight depends on tracking accuracy, transparency, and rapid response. Orbital uncertainty becomes human risk when astronauts are inside the target. The seventh layer is law. The United Nations long-term sustainability guidelines address policy, regulation, safety of operations, international cooperation, capacity building, and scientific research. They provide a shared vocabulary for responsible behavior, but they rely heavily on national action and voluntary alignment. That is useful. It is also weaker than a traffic code with patrol cars. National regulators now shape the real battlefield. The United States has moved toward shorter post-mission disposal timelines for satellites in low Earth orbit. ESA has pushed a zero-debris approach for future missions. Commercial customers increasingly ask about disposal reliability. Insurers study collision risk. Military planners study resilience. The market, the state, and the mission owner are all learning the same lesson through separate invoices. Debris policy will harden through procurement. Governments can require better disposal plans from contractors. Launch providers can require passivation standards from customers. Insurers can price sloppy behavior. Space stations can demand cleaner traffic nearby. Constellation operators can publish better maneuver data. The stick may be regulation. The sharper stick may be denied access to contracts and launch opportunities. The eighth layer is geopolitical advantage. A country with strong tracking networks, responsive launch, debris-resistant satellite design, and active removal services holds a strategic edge. It can protect its own systems and sell protection to allies. It can set standards before rivals do. It can define responsible behavior in ways that match its industrial base. That is the quiet power move. Standards become strategy. Catalogs become diplomacy. Insurance tables become policy. Cleanup vehicles become dual-use tools. A nation that masters debris management gains influence over the rules of orbit. China, the United States, Europe, Japan, India, and commercial firms all understand this in different ways. Each wants access, each wants credibility, each wants freedom of action. The actor that can operate safely in crowded orbits gets more room to maneuver, literally and politically. The horizon is clear. The next decade will bring more satellites, more maneuvers, more conjunction warnings, more debris services, and more arguments over who pays for cleanup. The political fight will center on three questions. Who gets priority in crowded orbits? Who must remove dead hardware? Who gets trusted to approach someone else's satellite? Those questions sound technical. They are sovereignty questions wearing lab coats. Space debris teaches the oldest rule of politics in a new altitude band. Freedom without discipline becomes disorder. Disorder becomes control by whoever can still operate inside the mess. Orbit is the high road of the modern world. Debris is the broken glass on that road. The nation that clears it, maps it, and survives it will set the terms for everyone behind it. The next briefing moves from junk to traffic control. Because once the sky becomes crowded, the real question becomes simple. Who directs the lanes?